Hey everyone, so today we are going to move on to solving quadratics, where I don't give you the formula, where you have to figure out what the equation is that you're going to solve. Alright, so start with this. This is a practice SAT question. Which of the following is an equivalent form of the function f above, in which the minimum value of f appears as a constant or coefficient? So it wants you to rewrite the quadratic, right, an equivalent form. So we're rewriting that quadratic where we can see the minimum value. Think about what that equation is. What type of equation is that? It's a quadratic. What's another name for the minimum? The minimum of a quadratic is your vertex. So they want you to rewrite it in vertex form. Right? So if I multiply that out, I get x squared plus 2x minus 24. So they want me to complete the square. So you could actually complete the square if you want to cheat. You could go through, right, it's not A or B, and figure out what that number is. So x half of 2 is 1 squared minus 1 minus 24. So it's D. Okay, so I want you to just think about this problem and see if you could figure it out. Use any method you want. Pause the video. So it says the perimeter of a rectangle is 220 feet. What is the largest possible area? So remember, perimeter is length and width. So 2L plus 2W equals 220. So the length plus the width has to be 110. So here's what I did. I went through and I figured out, okay, so if my width, right, my width is 10, right? Then this is 10. So 220 minus 20 is 200. So my length has to be 100. Right? If my width was 20, then it would be 90, and so on. So what do you think the answer is? Right here. So we want to find the largest possible area, so that's area is length times width. So what we could do is use the formula, the 2 length plus 2 width equals 220. Length plus width is 110. Solve for either L or W. So I'm going to solve for L. So L equals 100 minus W. And then we're going to substitute that into the area formula. So area equals 100 minus W times W. So we get 100W minus W squared. If you go through and find, right, so the largest possible, so this is an upside down parabola, and we're finding the vertex, right, largest possible. Most of these board problems we're finding the vertex. So if you do negative b over 2a, negative 100 over 2 times negative 1, we get 50. Wait, why is it 50? Oh, I wrote, this is 110, 110, 110, 110. Oh, so many mistakes. 10, 10, 10, 10. 110, that's 55. And then if you plug in, you get 55 again. All right, try this one on your own. The width of a rectangle is 4 less than the length. The width is 4 less than the length. Find the dimensions of the rectangle if the area is 18. Well, area is just length times width. Right, so area equals L times L minus 4. So that's L squared minus 4L equals, now we're setting that equal to 18. L squared minus 4L minus 18. We're going to do either factor, I don't think that's factorable. We have to use the quadratic formula. 4 less than the length. Yeah, nothing multiplies. That's 9 and 2, 3 and 6. So we have to use quadratic formula. So L equals, isn't my pen working? L equals negative b plus or minus the square root 16 minus 4 times negative 18 all over 2. Let's see what we get there. I got 88. Now, normally I would leave it like I would rationalize or pull out the 4, but I want the actual dimensions. So I'm going to just plug this in. So 4 plus root 88 divided by 2. And I got 6.690. That's with the plus. And let's see, I think the minus is going to be a negative. Yeah, it is. All right. So that's my length. So find the dimensions, 6.690. And then minus 4, 2.690. Let's multiply this to see how close that is. Times 2.690. You get 17.996. So you're pretty close there without rounding. All right. Pause the video, see if you can figure this out. An equilateral triangle has an area of 10. Let's see. One side of the triangle has a length that is 2 more than 3 times the altitude to that side. Let's see. One side of the triangle has a length that is 2 more than 3 times the altitude. How long is that side? So remember, area of a triangle is 1/2 base times height, or length, side times altitude. So our area, 10, equals 1/2. My altitude is A. The side is 2 plus 3A. See, multiply that through, and we get A plus 3A squared over 2 equals 10. So we get 3 over 2A squared plus A minus 10. I'm going to multiply everything by 2. Is that factorable? 60? Does anything multiply to 60? I don't think so. Oh, none of these are factorable. It's annoying. All right, quadratic formula. Negative 2 plus or minus the square root 4 minus 4ac all over 2a. So that gives me negative 2 plus or minus root 244 all over 6. That gives me the side, or the altitude is 2.270. How long is that side? And then I have to multiply that times 3 plus 2. So each side of this triangle is 8.810. That's it. All right, pause this, try it on your own. This is a quadratic formula, I'm pretty sure. One leg of a right triangle is twice the other leg. So here's my right triangle, twice the other one. The hypotenuse is 3 centimeters longer than the longest leg. Well, 2a has to be the longest leg, so plus 3. How long are the 3 sides of the triangle? All right, so we don't really have any, notice they didn't give us anything else, so we need some kind of equation here. So we're going to use, like, what's the equation we know for the quadratic formula, or not quadratic formula, for a right triangle is the Pythagorean theorem. So we're going to do a squared plus b squared equals c squared. Go through, a squared plus 4a squared equals 4a squared plus, let's see, because remember we're multiplying out 2a plus 3 times 2a plus 3. It's 6 and 6, so 12a plus a 9. My a's end up canceling, so that's kind of nice. Or not my a's, my 4 a's. All right, so I get a squared minus 12a minus 9 equals 0. And again, that is not factorable. So I'm going to use the quadratic formula. Negative b plus or minus the square root b squared minus 4ac all over 2a. Let's see. So I get square root of 180. So that gives me 12 plus root 180 divided by 2. So I get a is 12.708. Double that. I get 25.416, and then add 3, 28.416. So those are the three sides of my triangle. Okay, so now this one's pretty challenging the first time you see it, but once you get used to it, it's really not that bad. It's really popular in calculus, which is why I wanted to make sure to spend time on it. So we have a swimming pool, and it's 20 by 50. And it's surrounded by a sidewalk of uniform length. There's my sidewalk. The outer edge of the sidewalk forms a rectangle with an area. The outer edge of the sidewalk forms a rectangle with an area of 1,600 feet. What is the width of the sidewalk? So what they're saying is, so first off, it's uniform. So this is x and this is x. Okay? So if that's true, what is this whole distance? What is this length going to be? Well, we have the 20, right? Plus this piece, plus this piece. So that's 20 plus 2x. And then on the other side, we've got this side, the 50, plus this x, and then plus this x. So 50 plus 2x. I don't like how this is worded. The outer edge of the sidewalk forms a rectangle with area of 1,600. That's including the pool. So that's kind of unclear in this problem. So the area of that outside rectangle, the area length times width, is 20 plus 2x times 50 plus 2x. All right, so go through and now solve this. This you could do on your own. So 1,600 equals, let's see, 4x squared. We get 100x and 40x. So that's 140x plus 10, 1, 2. That's a plus. All right, so let's see. Subtract 1,600, 4x squared plus 140x minus 600. I'm going to divide everything by 4. X squared plus 35x minus 150. Ooh, is that factorable? 150 and 35. Let's see. That's 5 times 30. Aw, no. If it was adding, it would work. All right, we'll just use quadratic formula again. All right, so negative b plus or minus b squared minus 4ac all over 2a. Okay, so remember what we're finding here. We are finding the length of the sidewalk. So 35 squared. 35, oh my goodness, 35 squared minus 4 times negative 150, square root of 1825. So you get negative 35 plus or minus root 1825 all over 2. Let's see what that gives us. So I got 5. Right over here, 5.360, And then the other one would be negative. So that's the, so what is the width of the sidewalk? So that's it. All right, last one. A piece of cardboard is 4 times as long as it is wide. A 10 by 10 centimeter square is cut from each corner of the flap, and the flaps are folded up to form a box. If the volume of the box is 7,000 cubic centimeters, then what are the dimensions of the piece of cardboard? All right. So this is another very common problem. So let me see if I can draw it so you can get it. So we have, here's our cardboard, right? We're going to cut out these pieces that are 10 by 10. So now, once they're cut out, we have something that looks like this. And then what we're going to do is we fold along here. And then we fold it up. So then see this inside piece, this. And then we fold up. See, I need to write, that's bad. I'm going to do it like 3D. So that's this inside, right? This that I just drew is this piece. And then we go up. And we form a box. Okay? All right, so let's see what we can write on here. A piece of cardboard is 4 times as long as it is wide. So this outer piece was 4 times as long as it was wide. So if this is the width, this was 4W. A 10 by 10 square is cut from each side. So this 10 and this 10, that 10, 10, 10, 10, 10, 10. All right, so that means we need to figure out what this is. What do you think that piece is? Well, we took out a 10 on each side, so that's 4W minus 20. With the width, what is this going to become? Well, that's that whole W minus 20. And then what's the height of the box? Well, that's these are folded up, so that's a 10. All right, so now we figured out the picture. So now it says the volume of the box is 7,000. So how do you find volume of box? So it's 7,000 equals length times width times height. So we have 10 times 4W minus 20 times W minus 20. All right, so go through, multiply all that out, and then solve. Probably going to use quadratic formula again, right? Let's see. So this is, change this to blue. So I'm going to do the inside 4W squared. It's minus 80 minus 20. So minus 100W plus 400. We're going to multiply all that through by 10. So 40W squared minus 1,000W plus 4,000 minus 7,000 on both sides. 40W squared minus 1,000W minus 3,000. Divide by 40. So, is that 25? Yeah. 25W minus 75. Quadratic formula. 25 plus or minus the square root. 625 minus 4 times negative 75 all over 2. It's 25 plus or minus root 925 all over 2. Let's see. 25 plus root 925 divided by 2. I got the width is 27.707. And then that means that the length is 110. I ran out of space. I'll write it up here. Length was 110.828. That's it. It's a lot, but these are doable problems. I don't think they're overly hard, but maybe that's just because I've done them a bazillion times. All right, that's the lesson. Have a fabulous day.